covering is polynomial inequalities, okay? Which means instead of graphing equations, we're going to be using graphs to solve inequalities, so less than or greater than kind of problems, okay? So let's look at a few examples. All right, so this one is wanting to know where is x minus 2, x plus 3 less than 0. Okay, so what we're actually going to do is find the x-intercepts of this, which are the zeros, right? It's already in its factored form. So if I'm going to find the two x-intercepts that go with these factors to put on the x-axis, I just need to set each of those factors equal to 0, right? To get these x-intercepts. So x minus 2 equals 0 and x plus 3 equals 0. I would add 2's here. So that one's going to be x equals 2. Then I'll subtract 3's here to get x equals negative 3. So that's where the two x-intercepts of this are. At positive 2 and negative 3. So negative 3's x-intercept, positive 2's x-intercept. So what kind of a graph is this? Act like this is not in factored form. And if I foiled this back together, what is going to end up here times here? X squared, right? So we've done lots of x squared graphs. They're all going to make that parabola shape, okay? Now I just need to find out if this parabola is right side up or upside down. And remember, what determines that is if the x squared is positive or negative, right? Positive x squareds look like this, negatives flip upside down. So this would just be a positive x squared, right? If I foiled that. So now I know that this parabola is going to be right side up like this. And to find out where this is less than 0, that's all I'm going to need to know. Okay? 0 is the x-axis. So if I am less than 0, I'm below the x-axis, right? So what I want to include is this part of the graph. That's the part of the graph that's below the x-axis. And it wants to know what is that interval. So where does it start being below the x-axis? Negative 3. And it stays below 0 until it gets to positive 2. Now, remember, this is in interval notation, so I need to figure out parentheses or brackets, okay? I will always use a parenthesis if there's not an equal to bar here, right? That equal to bar is what tells you to put the number in a bracket and include it in what you're talking about. So since it doesn't have that, then these both get parentheses. So this is less than 0 from negative 3 to 2. Right? Here, we want to know where is x squared minus 14x plus 33 greater than 0. Okay, this last one was already in its factored form, so I could set the factors equal to 0 to find the x-intercepts. This one I need to factor, or it is quad, right? You could put this in your quad program to find the zeros or the x-intercepts. But if I did factor it, it's not that bad of a factoring problem. X and x for x squared. Now, I need to multiply the 33. So there's the two factor pairs. Where do they also have to add to? Negative 14, which means I'm going to use this 11 and 3 pair, right? I can't get any kind of 14. It doesn't matter what I do with my signs with 33 and 1. So now I'm going to use 11 and 3. In order to multiply to positive anything, all that means is your signs are the same, right? They just have to be the same as each other. So if I'm going to add these two numbers together and get negative 14, they're just both going to have to be negative, right? Which are same signs, so it's still positive 33. And then now it's like this one, you'll just set these equal to 0 to find your x-intercepts. So add 11 here. So x equals 11, and here add the 3. So x equals 3. Okay, so I know I'm going to have x-intercepts at 3 and 11. And now I just need to know whether or not my parabola is regular or upside down. So I just need to see what the x squared is. Since it's positive, I'm going to have a regular parabola. But what does this one want to know? This one wants to know, where is this greater than 0? Remember, 0 is your x-axis. So where is it greater? It's going to be greater above the x-axis. So I'm talking about here, and it goes below, and then what happens here? It goes back above. So there's two separate intervals here where it's above the x-axis. And remember where the number line starts. Starts at negative infinity and goes to positive infinity. So what is this interval? It starts above the x-axis at negative infinity until it gets to 3. Don't want that. That's below. Where does it start being above the x-axis again? 11 to infinity. Okay? And again, I'm using parentheses around my numbers because I don't have that equal to bar. Okay? So do you see why this one is one interval? It just depends on what part of the graph you want to include in your intervals. This one I had two separate intervals because it wanted to know where this was above the x-axis, which was two different places. All right, let's look at another example. X squared minus 3x minus 30 is greater than or equal to x minus 9. So on this one, I'm going to have to do a little work before I can factor or put it in my quad, because I need this side to be what? What are the other problems? What has it been? 0. So I'm just going to move both of those terms all in one step to the other side. I need to knock out the plus x with a minus x and minus 9 with a plus 9. Now, when I do those same two moves on the other side, make sure you line them up under their like terms, right? So the minus x will come under this x, and the plus 9 will come under that constant. Let's see what's left. X squared, negative 3 minus 1 gives me negative 4x. Negative 30 plus 9 is negative 21, and it wants to know where is that greater than or equal to 0. So again, you could put this in quad, and we'll start doing that here in a little bit. X and x for x squared. If I'm multiplying to equal negative 21, first of all, if you're multiplying to equal negative anything, you're going to have different signs, right? One positive and one negative. It doesn't matter where you put those signs. What does matter is the numbers that you put with them. So let's see, how do you get 21? So just looking at the two options, I'm trying to get negative 4. Not going to be able to do that with a 21 and 1. Doesn't matter what you do with your signs. But what about this 7 and 3 pair? Remember, I already know that I've got one positive and one negative. What do I need it to end up being? Negative 4, which means I need negative 7 and positive 3. So put the second 7 with the negative, 3 with the positive. And then find your x-intercepts. So what's this one going to end up being? If it's x plus 3, and I set it equal to 0, and subtract the 3 from both sides, I get negative 3. And then do the same thing with the x minus 7 factor. Here, I will add 7s. So here's my two x-intercepts. Negative 3 and positive 7. Negative 3, positive 7. X squared is positive. So it's a right side up parabola. What does this want to know? Where is this greater than or equal to 0? So again, I'm talking about above, right? Because it's above 0. So there's the part of the graph that I want to include. So it starts being above all the way at negative infinity. Above, until right here, which is negative 3. Now is when you're going to want to include that negative 3, right? Because it wants to know where is it above and equal. So it equals right there. So that needs a bracket. And what else? 11 to infinity. 11 has the bracket, again, to include it. Oh no, why? Well, that's super frustrating.